Hello, this is Vainavin from JNTGV. My roll number is 23VV1A1260. Today I am going to solve some problems in computer networks. The question number 1 is, it is desired to send a sequence of computer screen images for an optical fiber. The screen is 3840 into 2160 pixels, each pixel being 24 bits. There are 20 screen images per second. What data rate is needed? Bits per frames is equal to pixel per frames into bits per pixels. 360 3840 into 2160 into 24. Then we will calculate the answer with 24 bits per frame. Then we get 199,065,600, and the last answer is 199,606,6000 bits per frames. Calculate bits per second. Data rate is equal to bits per frame into frames per second. We are going to multiply the answer with 60 as frames per second. Then the final answer will be nearly equals to 11.94 GB per second. Next, we go to question number 2. Television channels are 6000 MHz wide. How many bits per second can be sent if 4-level digital signals are used? Assume a noiseless channel. Let's see, here we are using the formula C is equal to 2b log 2m, where b is equal to 6 into 106 edges and b is equal to 6 into 10 to the power of 6 edges, where m is equal to 4. Therefore, the maximum data rate is equal to 24 Mbps. Now the third question, if a binary signal is sent over a 3 kHz channel over signal to noise ratio in 20 dB, what is the maximum achievable data rate? Here we are going to again use the formula C is equal to 2b log 2m, where b is equal to 3000 edges. Binary signals m is equal to 2m is equal to 3m is equal to 2. Therefore, the maximum achievable data rate using formula is 6000 bps. Let's move to the question 4. 10 signals each requiring 4000 Hz are multiplexed onto a single channel using frequency distribution multiplexer. What is the minimum bandwidth required for the multiplexer channel? Assume that the guard bands are 4000 Hz wide. Number of signals, that is m is equal to 10 bandwidth per second per signal, that is ps is equal to 4000 Hz. Guard band between adjacent signals, that g is equal to 4000 Hz. Formula for total bandwidth is equal to nbs plus n minus 1 into g. Then the answer will be 43,600 Hz. Let's move to the question 5. Why has the PCM sampling time been set at 125 microseconds? Telephone channels bandwidth is equal to 4000 kHz according to Nyquist theorem, where frequencies are greater than or equal to 2 into frequency max, second frequency, that is 2 into 4000 is equal to 8000 samples per second. Sampling period t is equal to 1 by frequency, that time period is equal to 1 by frequency. Then the answer will be 125 microseconds. What signal to noise ratio is needed to put a 1T carrier on a 1 MHz line? Here we are going to take the bandwidth is equal to 1 MHz, that is 1 lakh MHz. 10 lakhs multiplied sorry. Data rate, 1 P1 carrier 1.544 Mbps. We use here a formula B into log to 1 plus SNR. By using this formula we get the answer is equal to 2.1 dB. A cable TV system has 100 comical channels, all of them alternating programs with HC. Is this more like TDM or like FDM? Each TV channel is assigned a different frequency band. All channels transmitted simultaneously frequency domain. It is FDM, frequency distribution multiplexer. A cable company decides to provide internet access to our cable in a neighborhood consisting of 5,000 houses. The company uses a coaxial cable and spectrum allocation allowing 1000 Mbps downstream bandwidth per second. To attract customers, the company decides to guarantee at least 2 MB per second downstream bandwidth to each house at any time. Describe what the cable company needs to do to provide this guarantee. Bandwidth guarantee per hour, that is given 2 Mbps. Total required 5,000 into 10,000 Mbps is equal to 10 GB per second. Available cables available per club is equal to 1000 Mbps. Number of cables required, it is 100. Houses per cables 5000 by 100 is equal to 50 houses. These are the 8 problems we have solved in this video. Thank you for watching. Thank you.